Okay, the first part, right? Top left, body. That's the main body of the total assembly. Picture name, change picture name. Right? That rectangle, gave it dimensions and then use pad feature, right? For a depth of how much? 15, right? Bottom one, you see, 15 is the depth. Okay, and then we have drawn a circle on top of that surface. What is the height of the pad? 50, right? As per that, right? 50 from the previous surface. Now another feature on top of that. So we'll select a surface, sketch on it. We're using that line as a reference, right? To draw that ellipse, right? 60 is the distance from the origin, right? Use mirror to get that same line, 3-point arc. To specify 2 points and then radius, and then mirror it. Right? Use mirror. You have to specify an axis about which to mirror and the entities to mirror. Now, corner, reading that corner. Right? What is the radius? Observe the top dialog box for radius 18. Okay. Okay, it is 60 from that corner, right? That's why. And now same thing, 18 radius, pad for a depth of 15, right? And then those circles. No, actually the middle part has to be taken, right? Middle material. So we'll use group for and in our profile, right? We observe that dashed lines there. And this, so it's basically, what type of view is it? Is it half sectional? No, right? We have cut it like this. Let me show you with annotate. It's been cut like this. Okay. right? It's been cut like this. Only the front right part is cut. That's why you're having hatch here and no hatch here, right? So just to be able to show the details, we have only cut it this way, quarter model. Okay. So you can call it quarter sectional view, okay? If, for easy understanding of this view. So that's why you get that hatch on the right side and no hatch on the left side. Okay. So we are trying to cut this portion, right? Because this portion is empty. That's why we have this dotted lines and we cut it. You see, this part is hash, that is material is here and there is no material here when we are cutting it here. So what does this mean? If it is white here, that means there is no material here, right? So that's what it indicates, and therefore it is hollow. So we'll draw this profile and then we'll use groove to revolve it about this axis so that we can remove the material. Okay. What is the height? Okay, let's just giving random dimensions and then we'll fine tune it. Now we'll give the exact dimensions. So we are adding up dimensions here. 15 plus 50 plus 15. Right? Observe in the drawing 15 bottom, middle 50, and then 15, like that. And now this from the middle axis, it is 16.5, 33 by 2, right? And that is 42 by 2, 21. And 65 on the top. And now it moves through to remove the material, right? Now for that circles. Right? Diameter and the distance from the center. Diameter is 12, right? Distance from the center, that is origin. Distance from the origin is 84 by 242. Right? Now we'll use mirror, or yeah, he's using pattern. We could even use mirror. Okay. Okay, firstly pocket and then pattern it. Pocket to remove the material of the next. And then rectangular pattern, right? Specify the instances to spacing between the instances. This is the spacing. We can reverse the direction, right? It might take in the other direction, right? You can reverse it in a desired one. Specific spacing 84, right? That's how you get that body, right? Very simple, right? 3 extrudes, that is 3 pad features we've used, right? This one, that one, and the top, and then and the individual sketches, of course. This rectangle for the first pad, that circle for the next pad, and this elliptical type of profile for the third pad. And then we used another, we used that plane for front plane to draw that groove, inner groove profile with inner material to be removed. And then this selected the top surface. I have drawn the circle, use pocket to remove the material, and then use pattern to have it on both sides. Right? Clear about this body? Right? Those are the steps that you will be performing. Okay. Similarly, for the gland, second part, okay, selecting a plane, sketching, right? We've used circle and then pad, okay, and then on top of that, we're drawing another profile, centered rectangle, okay. We have given, okay, we are only taking that line, use mirrored line again, same thing, just as we have drawn earlier, 3-point arc, right? So those points will be for reference. The axis endpoints are for reference. So we can draw this 3-point arc, right? How do you draw 3-point arc? You specify 2 positions and 1 radius, and then use a radius to have that corner, right? And have it on the other side using mirror, right? About the horizontal axis, right? Or you can use another feature also. Same, just like we had done earlier, specifying the distance from the horizontal axis, right? So that we can, using again corner, yes, specifying the radius so that we can have it, right? It's your second part here. We're drawing this now, okay? That's all right. Yes, okay. He's using, he'll not, we could have done it afterwards, right? This circle, we could have done later, but he's doing it right now. Then we can save on some steps, right? We've drawn that circle, given the diameter, distance from the center, from the horizontal axis, 42, diameter of 12, right? Now use mirror. Okay. And now that, yes, the top, you see the profile. So we'll draw a circle, we'll pad it, and then we'll remove material. Okay. Diameter of that is 50. We'll use pad feature, right? Pad of how much? 9, right? Then we'll have that feature, and now we'll remove material just as we have done earlier. We'll remove the inner material. You see, it is hatch here and no hatch here. So that indicates there is no material in the middle, right? Wherever there is hatch, there is solid. So, by the way, this is the side view. Okay, top view, front view, side view of what? Of this second part is it? Gland. Yes, second part. So we are drawing that inner profile, right? Using freehand lines, and then we'll give the final dimensions later. Now, right? right? Those are dimensions. Observe the bottom left. 69 minus 12, right? 69 the total one. From the top it's 12, so 69 minus 12 gives you 57. And now for that final profile there. Twenty-three, 46.2. Right? 3-point arc to specify 2 points and radius. So I've selected the points, you just have to specify the radius, right? Now we'll use groove to remove the material. Define the axis, and that's how you get that. Clear? Applying the material to have a color. The visualization. Right? That's about your second part. Now the third part is that bush, right? We're drawing a profile and then we will revolve. That is basically shaft, right? In CATIA, you call it shaft. You want to add material using an axis, around an axis. So we're giving random dimensions. Now we give the final dimensions. Right? 21, 15 plus 6, right? I think we have covered this in the other video, right? Third part. Yes, I believe. Right? Anyhow, we'll go through quickly. Right? We're just drawing the half part of it and then using shaft. Proper dimensions. And that slant line, right? Angle has to be given either from here 15 or here 180 minus 15, right? Distance, the edge. Now the angle, right? 180 minus 15 gets you 165. So we use shaft to revolve about an axis, and that's how you get that bush, right? Apply the material. And start we have covered in the other video, right? So that was a revision for you, so that we can even have the recording. Okay. Now let us go to the assembly part, right? We have taken first part, right? We have seen until, yes, we have imported the first part, given it the color because we had not given it in the part design. That's why. So the assembly, this is the assembly part, isn't it? We are calling different parts. First part body was called now gland. Okay, it's calling the bush first. You see? Moving it. Remember, you observe that anchor there, that's fixed. The first part. I'm trying to give some constraints here. Right? What constraint did we give? concentricity. So taking use of the constraints, you can define the relationships, right? We're calling start, right? That's there. You can move it. Same axis, make it coincident, right? First step. And now we can use snap to have it there. If we switched on the constraints here, we can see what exact constraint is using, because the dialog boxes are not open, right? This is the feature tree for the body. Okay, now he's using pattern to get it. These are two styles, right? So instead of calling it again, we just use pattern. Okay. Now gland. See, it came in the default position. We are moving it. Constraint. Okay, making it coincident first about that axis, so that they have the same, they're in the same axis. Okay, coincident about the same axis. Now coincidence about this, right? Stud also, because the stud is passing through both the gland and the body. Right? Now offset, I have to specify some distance, 25. You see, so you can even do it this way, right? If you don't want it to attach, you can specify the distance between the entities. So that's how you get no, not it came there, right? Move it and select any axis, okay, to move it wherever you want to, X, Y, or Z. Making it coincident about the axis first, and then we'll use contact to have a contact, right? Now again pattern, right? Yes, rectangular pattern, specify the distance. You can have it on the other side, right? Now those constraints were on it earlier, you see, so that we can have an idea what constraints are applied. We can hide it, hide show. Okay, it's creating the middle shaft, I guess. Okay, circle and then shaft, add feature, right? Applied a color, introduce it here in the middle. Okay, so that you see that uh, bush, right? There is some gap between the shaft and this body, right? That the bush will take care of. Is it clear? This is for rendering purpose. We have heard, right, about in the geometric modeling for downstream applications. I gave you that one application is rendering, and we can have a real-time kind of model to make it realistic. You see, so that we can use it for catalogs or any other presentation meetings or quotations, etc. Right? Doubts? That was your assembly design, right? Very similar, just that you have uh, firstly part designs and then assembly, basically where you apply the constraints, right? You see, when you click on that constraints, okay, it will show you all the constraints that are applied. You can modify them, right? Edit them, delete them, okay? And yes, I told you that if there are changes in the part, okay, let's say stud, okay, I open the stud file. I've already saved this assembly file, right? Now I open the stud file, okay. I have changed the diameter of this stud, okay, this diameter. Will it reflect here in the assembly or not? Will it change in the assembly also if I change in the part design, individual part? Yes or no? Yes, because you've given the part address, right? In the assembly, you specified what part was taken. Any changes to that part file will make changes in the assembly also. Okay, it will reflect. That's the advantage. But if you don't want to have those changes, you have to take that previous file, okay, copy it, and then make changes there, okay, so that it does not reflect here. If at all you want to make changes in the part file to be used in another assembly, you can make a copy of it, right? Place it in another folder, and then you can modify it so that those changes will not reflect here. Is it clear? Okay, then if there are no doubts, then we'll end the meeting. Okay. Okay, thank you.